megahertz license-free band. So it's globally available, and again, and that's this particular part. So this is Bluetooth. Here we see cordless phones and baby monitors with wireless lens. This is unused as well. And we saw that we also have here Zigbee operating. Alright, so the Bluetooth radio link, it's split up in lots of different frequencies. So we have, you do a frequency hopping spread spectrum. So we start with the baseline frequency and we add, depending on k, a certain amount of megahertz. And you do a bunch of hops per second and so forth. You use the idea of time division duplex. In a sense, it means a separation of transmission and reception in time, and the units alternately transmit and receive. Well, we're not going to talk about this like a digital signal processing course, but it's kind of interesting. As an engineer, throughout this whole study, at some point, when you think about maybe this more higher layer sort of programming course that we have here, does use all kinds of engineering mechanisms. And they are hidden right now in this course, but they are existing. So it's kind of cool that you get to see this whole picture. At least that's what I think is fun. Alright. Alright, so Bluetooth targets a large number of independent communications active in the same area at the same time. Each 1 megabit per second channel is shared by a limited number of participants. Theoretically the total bandwidth is of course 79 megabit per second because you have 79 channels. But it's much less because you will have a bunch of different transmissions going on. So you need to share. That's what we saw, right? Alright, so okay, so I have again this picture, bloop, 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 bloop. So here we have the idea of a master and a slave. You will be programming a master and a slave. Your Bluetooth, you will have your remote controller giving commands to your robot and or the vehicle, and the vehicle may transmit things back as well. So you need to agree on a hopping sequence. The Bluetooth devices can operate as masters or slaves. The master notifies the sequence to be used. The slave units use the master ID to pick the sequence, and so forth. You will notice when we get to that laboratory, you actually look at a YouTube video, and you need to literally, in a hands-on way, set the settings of your Bluetooth device. It's a different type of programming than what you are used to, but you can just set it all up the way you want it to be. Alright, so Bluetooth communication takes place over what we call piconets. The piconet formation is initiated by the master, and all the other participants are the slaves. The number of participants is limited to 8, so 1 master and 7 slaves. The channel capacity and addressing overhead is arranged, and each slave is assigned a local and unique identity. So the master-slave roles last for the duration of the piconet, and then you may set up a new one with a different master. Alright, so the slaves have a direct link to the master, and there may be point-to-point or point-to-multipoint connections. So you will only be using it to communicate between those two Bluetooth devices of yours. By the way, you will be with 4, so you will have 4 Bluetooth communications happening at the same time. So there may be interference, so you may want to make sure that you use a slightly different channel sequence or whatever that there is, but that is but that will resolve itself pretty much automatically, I would say. All right, so so the master performs medium access control, blah blah, schedules traffic, and so forth, all kinds of stuff. Now you do not need to worry about like a larger network. You're only going to talk about your application where you communicate between two. So what kind of states can we have? We can have standby, you can try to connect, you can be active with transmissions, and you may also be standby, but you know, you're sniffing whether something may be ready for you. So on an inquiry, you try to you know, do device discovery, so you figure out who is in your neighborhood, and then you get signals back, and that means that you get to know those. So you discover the devices. Paging, what's this? So you invite others to the Piconet. So you establish links with in proximity. So that's what we do here. And then maybe there's others that you will recognize, and they will get included as well. So we have the master, we have active slaves, and a bunch of others that are sort of standby, or what we call parked slaves. I do not exactly know what that means. And then yeah, so not sure what this is about. Okay, link formation. So all of this is happening by your Bluetooth device. Error control, the usual stuff. You again want to make sure that you make your communication reliable, and you can you know, use different kinds of methodologies for it. So there is an error correcting code that you may want to use, and that will actually correct some of the bit flips in your packet. ARQ stands for, I really forgot now. Okay, or cyclic redundancy check for checking errors. Alright, so what is the packet format? So you have an access code, a header, and a payload. And all of this will be oblivious to you when you're using your Bluetooth devices. Effectively, the payload can be something like voice or data. The data itself may have a header and a CRC. So CRC is a check on whether the data was not corrupted. And you're going to transmit as a master a packet, and a slave can respond. And you have different time intervals during which all that happens. And so the master and the slave need to be synchronized, and that will be done you know, by, for example, sending those header sequences. You'll start listening in, and then you will also figure out, oh, the master is transmitting right now, so that means that I can transmit only later after a certain time, and so forth. Alright, so the access code, oh, here we talk about the access code, is the address of the slave in the Piconet. There's a kind of packet that you could transmit, and a whole bunch of other bits that you can use. So you can have multiple Piconets. They can work independently, but they can also overlap, and that's done over here. And so you can have a node that's connected to this guy and to this one, and so you create in this way bridge nodes. So that's pretty cool. So you can connect from one Piconet to the other. So this particular one can now function as someone who forwards packets. Alrighty. Okay, we have all this stuff again. And we have power management. So some more details about that. And Bluetooth on the market. So is this a picture of what you have? Maybe not. I'm not sure. But there's a whole bunch of places where you can buy all kinds of you know, products that use Bluetooth. All right, so this was, any questions about this part? And then we'll go for Wi-Fi. Okay, we'll do that too. You know, I don't give any real details, of course, but I'll just familiarize you a little bit with what's going on with these types of communication protocols. And maybe you can also realize how complex it really is. It's a real engineering feat to make that happen. So because we're often so much to the side as observers using the products, you often do not really recognize what goes into it. So it's really cool to see this happening. And you know, Wi-Fi is yet another um, um, it's yet another type of wireless technology. All right, so it's used for a wireless local area network, and there are a bunch of standards. So there's an alliance again, just like you had the Zigbee alliance, and the Bluetooth happens to be developed by Ericsson, but is public, so you can use it. And so that's what happened here. So there's the Wi-Fi certified logo that you may have seen. So it means that you know, if you are certified and so forth, then several checks, you satisfy the standards, and several checks have been done, and your product is tested. And there's interoperability between, of course, different devices that are certified as well. So, for example, you may have what we call Wi-Fi hotspots. You can have pay services. You can have like these types. You can have free Wi-Fi, for example, one in Springfield. So then you have different places, as an example, different places where you can have free Wi-Fi and you can connect to that. That's what we do with our mobile phones, right? So brief history. So yeah, so it has been, so this started, so this was ratified in 97. I didn't even know it was that late. But you know, I got my PhD in 97 also, but I already worked for Philips for a year. And I remember working on, you know, the combination of voice, representing voice with so compression, with error correcting codes and transmitting that wirelessly, and how that would be. So that was around this time. That's kind of interesting. Okay, so the standard. So again, you again have all these layers. It's the usual stuff, and again it's explained what is done in every single layer. So the standard tells you what's going on. Again, we have this free range that you can use. So it has 11 channels, 3 non-overlapping, and supports rates from 1 to 11 megabits per second, but usually it's 4 to 5. And it uses direct sequence spread spectrum technology. So you can see the digital signal processing community had a great impact in all these different wireless communication standards. The techniques developed over the many decades definitely got into these products. And remember, in those days there were so many more new academic developments in that area too, which is pretty cool. So I'm curious, I haven't followed it, but I'm curious how that may have taken effect in newer standards maybe. Alright, so anyway, so this standard is an extension of this one, blah 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 blah, and a whole bunch of details. So I will not go over all of this. You can read it. Again, you have some advantages. There's no cabling. Again, it's wireless. It's the usual advantage. It's easy to set up, scalable, and so forth. And I heard that, yeah, right. Okay, so disadvantages: the speed is slower than a cable. The range is affected by various medium. That's kind of interesting. It travels best through open space. It's reduced by wall, glass, water, etc. because you get reflections actually. And also, if you, for example, are in a car, then you would then the reflections from the building would come to you as well as your speed, and you get what we call a relay fading channel. I don't know whether you've heard of that. And you know, you want to optimize your coding, like error correcting codes and your physical layer to work for that. But in this particular case, it's kind of more sensitive to where you are. And sometimes you actually notice that, by the way, with your mobile phone, if you're thinking about connection to through your Wi-Fi to do some free network or something. All right, so there can be unauthorized access, compromising of data, denial of service. So security, you may want to add another layer on top of that in your application. So you have some strategies. So block your service set identifier from being broadcast, change the default network name, change the default access point password, center the access point in the middle of the building or the house, things like that. So every network device has a unique MAC address. It would be good, right? So that's always done. At least that's the idea. So the MAC filtering only allows certain addresses to access, and you can use it. You can use this in home, etc. Okay, what's this again? The wired equivalency protocol. This is a certain encryption technology. So we use a certain stream cipher, as it is called. It is one that does not encrypt in blocks, but you push, chunks of data in, and it sort of in real time keeps on encrypting that. So the different versions apparently, and so forth. So that you could potentially add to your communication protocol. So that would give you some privacy. That would be great. So this is something else. Replaces WEP, uses yet other mechanisms that hopefully bring out better security, and so forth. And so this one, and this is yet another one. It's also designed to replace WEP. It uses now the advanced encryption standard. It has become much cheaper to implement that as a hardware unit. It's not that costly anymore, so why not use it if you have it on your device anyway? And then why not use this protocol, because that would give you, again, much better level security, like government level security. And then there's authentication protocols on top of this, and so forth. You can create a virtual private network, that's right, so a virtual tunnel from remote device to the server. So you effectively do not really see what's happening. It seems like there is direct communication link, but all kinds of things is added to it, including an encryption scheme and authentication. And it works across the internet. So, yep. So there's some other things in this slide deck that are also part of it. So what is a firewall? So it can even include firewalls to also protect your security. So you may have heard of that. So you can look at this too. And why do we have Kerberos on here? So I forgot why that is. But this is yet another mechanism that is doing authentication based on key distribution. Quite interesting. It's a really nice um, mechanism, I must say, but but it's somewhat old-fashioned. It uses an older encryption standard. And then bringing it all together, so you want to do any combination of these security techniques on top of your Wi-Fi communication. And the more security, the more of a hassle. So you want to make sure for what you do this and what kind of application you, what are you building this for? So, for example, if you want to connect with your mobile phone to something, you want to connect because you're in a senior design project, right? And you want to connect through Wi-Fi to what? A pellet smoker? All right. So, well, from a security perspective, what does it mean to hack into the system, if you will, right? So, do you do you want? I'm just. I mean, this may be just of a fantasy, but do you want an insurance company to find out that you are smoking at a certain rate, so the data somehow gets leaked and your insurance policy goes up? I'm just saying something, right? It's kind of funny, but yeah, exactly. You could do that. Yeah. So, but anyway, you only go so far. So now you see that when you're starting to think about it, you're starting to think also about certain risk scenarios, right? So if you're an engineer, you're going to think about the risk that you're willing to take and what not, and you do that in collaboration with the other business teams, like those who make those economical decisions for the company. So you as an engineer would come up in front of, say, you have this meeting and a product is being discussed, like every quarter, say, right? So you're up there and there are there's the CTO, the CEO even, the CSO of sales, all these people, right? And you're saying, well, we have a great product and so forth, you know. We have kept the cost pretty low, that's great for our business, but there's, no security. So here are the scenarios that could go wrong. What's the impact that it could have on our company? So what's the liability that we have? Well, then you start to wonder what you want and what not. So it's usually a decision being made at a much larger, bigger scale. It really needs discussion. But most people, especially 10 years ago, or in those positions, didn't know anything about security or security risks. So it's a very difficult topic to talk about. So that's why it's actually a good thing to have a little bit of an understanding, because it does impact how you are going to, as an engineer, what you're going to do. You need to give intelligent professional feedback to the people who make these risk and business oriented decisions. So you want to be able to really tell them, educate them on what can happen. For example, what we talk about now, who cares about security, right? But it's also short range. So I mean, who can be in there, with this Wi-Fi communication? So I don't know. But suppose you have a file server in a cloud, and no kidding, there is indeed disk encryption on the file server, but where are the keys stored? On the inner spiral of the disk. I mean, it's ridiculous. So if I get a disk, I can look at the inner spiral, I can decrypt the whole thing. So as a remote adversary, I may have a problem, but we have to be very careful about these kinds of methodologies. So people who did that, maybe that's not done anymore, but since I worked in industry, I knew that where I worked that had happened. The point is that that you need to educate your colleague engineers about risks surrounding both safety and security, right? And what to do with it. So it's pretty. So I hope you will also get that out of this a little bit. It will be fun. For you to be able to have intelligent conversations, with your future bosses and team members. So that's it. So we have done all of this pretty fast.